33 by 22 and 51 by 22. Now we will try to find the center of mass of a two particle system. So here we have two particles with mass. This is m2 and this is m1. So the center of mass of m2 is c2 and center of mass of m1 is c1. Now we'll find the center of mass of this two particle system. So as we have seen that the center of mass is nothing but sigma mi xi by sigma mi. So let's say that the origin of our reference system is at C2, that is this point. So to find the center of mass, first we'll expand this expression, that is m2 into x2 plus m1 into x1 by m1 plus m2. Now x2 is the distance of center of mass of m2 from the origin of our frame of reference. Since the origin of our frame of reference is at C2, so x2 will be 0. So this will be m2 into 0 plus m1 into x1. x1 is the distance of center of mass of m1 from the origin of our frame of reference. Now this distance is nothing but c1 c2 . Let c1 c2 is equal to L. So we have our center of mass as m1 into L by m1 plus m2. So if this is our center of mass, then the length of C2C, because this length is from the origin of our frame of reference and the origin is at C2, so the C2C would be m1L by m1 plus m2. Also we have seen that the center of mass of a system of particle is at such a point so that the moment of all the masses with respect to that center of mass is 0. So it means that moment of m2 with respect to point C is m2 into C2C, and moment of m1 with respect to point C is m1 into C1C. So the location of center of mass will be such that m2 into C2C is equal to m1 into C1C, because then only the moment of all the masses with respect to center of mass will be 0. Now let's see one more solved example. Suppose there is a circular disk of mass m. The radius of circular disk is r and the center of the disk is at C. Now a hole of radius r by 2 has been punched. So this white portion is the hole and CC dash is r by 2. Now we need to find out the center of mass of the remaining portion of the circular disk, that is center of mass of the shaded region. So to find this, first let's find out the mass of the shaded region. Since the area of entire circle is pi r square and the mass of this entire disk was m, now a hole has been punched off, so the area of this hole would be pi into r by 2 whole square, that is pi r square by 4. So since the mass of pi r square area was m, so the mass of pi r square by 4 area would be m by 4. So the mass of the remaining portion, that is the shaded region, would be m minus m by 4, that is 3m by 4. Now what we'll do is we'll take this circular disk as being constituted by two parts. One is the shaded region of mass 3m by 4, and one is this hole of mass m by 4. Now the center of mass of this complete disk without any hole will be at C. So now this problem reduces to the following, that is, we have two masses. One is of mass 3m by 4 and the other one is of mass m by 4. This is the center of mass of mass 3m by 4, that is C dash. This is the center of mass of mass m by 4, that is C double dash, and in between there is a center of mass of these two particles. So as we have seen, the location of center of mass would be such that C dash into 3m by 4 will be equal to C double dash into m by 4. Now C double dash is nothing but r by 2, the radius of the hole. So r by 2 into m by 4 will be equal to C dash into 3m by 4. So here we can cancel out m and we can cancel out 4. So C dash is r by 6. So this length is r by 6. So the center of mass of the shaded region would be at a distance r by 6 from the center of the circular disk. Now let's define center of gravity. Center of gravity is a point through which resultant force of gravitational pull always passes, irrespective of the orientation of the object. In the uniform gravitational field, the center of mass and center of gravity of an object always coincides. And as was the case with center of mass, center of gravity of a system of particles can also be defined as the point about which the sum of moment of gravitational forces on all mass particles is 0. So this is all about center of gravity. It is quite similar to the center of mass concept that we have discussed earlier. Now we will see how the center of mass is related with linear momentum. Linear momentum of a mass particle is defined as the product of mass of the particle and its velocity. It is a vector quantity and the direction of momentum is same as the direction of velocity. So we write P is equal to mv. Now linear momentum of a system of mass particles is defined as the vector sum of the linear momenta of all the particles enclosed in the system. So suppose we have a system of particle here. Suppose we have a particle m1, m2 and m3.